Hey everyone, and welcome. Today we're tackling a Leetcode problem called Check if digits are equal in string after operations 1. It sounds a bit complicated, but don't worry. We'll break it down step by step into something super simple. Let's get started. Okay, so here's the main idea. We're given a string that's made up of only digits, like 3902. Our job is to keep applying a special operation on this string over and over again, until it's only 2 digits long. Once we get it down to 2 digits, we just have to check if they're the same. If they are, we return true. If not, we return false. So the whole game is about shrinking the string. We start with some initial length, maybe 4 or 5 or more. We perform an operation, and it gets shorter by 1. We do it again, it gets shorter again. We keep doing this until the string has exactly 2 characters left. At that point, we stop and make our final comparison. So how do we actually shrink the string? The rule is pretty specific. We slide a window across the string, looking at 2 digits at a time. For each pair, we add them up. Then, we take that sum and find the remainder after dividing by 10, which is just the modulo 10 operation. This result gives us a new digit for our next string. Let's walk through the example from the problem, which is 3902. First, we look at the first 2 digits, 3 and 9. We add them to get 12, and modulo 10 gives us 2. So the first digit of our new string is 2. Next, we slide over and look at 9 and 0. Their sum is 9, and modulo 10 is still 9. Finally, we look at 0 and 2. Their sum is 2, and modulo 10 is 2. So, after one full pass, our original string 3902 becomes 292. Okay, we're not done yet, because 292 still has 3 digits. We need to get it down to 2. So we do the exact same process again. We take the first pair, 2 and 9, that adds up to 11, and modulo 10 gives us 1. Then we take the next pair, 9 and 2, that also adds up to 11, and modulo 10 is also 1. So our new string is 11. And now we stop. The string 11 has a length of 2. The last step is simple. We just compare the 2 digits. The first digit is a 1, and the second digit is also a 1. Are they the same? Yes, they are. So for the input 3902, the final answer is true. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. The logic is the same everywhere. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. So what's our strategy here? Well, the problem description is basically a recipe. It tells us exactly what to do, step by step. Since the strings we're working with are pretty small, we don't need a super clever or complex algorithm. We can just do what it says. This approach is called a direct simulation. We'll write code that mimics the process we just walked through by hand. Alright, here's the Python code for this simulation approach, taken straight from the editorial. It might look a little dense at first, but we'll break down how it works. The core idea here is to modify the list of characters in place, which is a clever way to avoid creating brand new strings in every single step. Let's focus on the main part. First, we convert the string into a list of characters. Because strings in Python can't be changed directly, the 2 for loops work together. The outer loop is basically counting how many times we've shrunk the string. The inner loop is what does the real work for each pass. It goes through the active part of the list, calculates the new digits just like we did by hand, and then, this is the clever part, it overwrites the values at the beginning of the list. So the result of each pass is stored right back into the start of the same list. Finally, after all those loops are done, our shrinking process is complete. Because we've been overwriting the start of the list, the final 2 digits that we care about will always end up in the first 2 slots, that is, at index 0 and index 1. So the return statement just has to compare those 2 values to see if they're the same. So how efficient is this? The time complexity is big O of n squared. This is because we have nested loops. The outer loop runs about n times, and the inner loop also runs about n times, where n is the length of the string. So n times n gives us n squared. For the space complexity, it's big O of 1, or constant space. This is because we're doing the clever trick of modifying the list in place, so we don't need a bunch of extra memory that grows as the input string gets longer. Alright, before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So, I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. Alright, as promised, here is the full solution in Java. You can see it uses a while loop to keep going as long as the string length is greater than 2, and it builds a new string in each step. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. The logic is identical to the Java one. A while loop that continues until the string length is 2, and building up a new string inside the loop. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Once again, it follows the exact same pattern. This really shows that once you understand the core logic of the simulation, you can apply it in pretty much any language. So let's wrap it up. The main takeaway here is that sometimes, you don't need a fancy algorithm. A direct simulation, just doing exactly what the problem asks, is a perfectly good solution, especially when the constraints are small. We also saw two ways to implement this: the in-place modification, which saves space, and the more straightforward approach of building a new string at each step. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems. So if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.